Whether you think they're a nail-biting finish of a match, or an anticlimax with neither team being able to best the other, penalty shootouts are a staple of football. The conventional method of penalty kicks begins with a toss, with the winning team choosing to kick first or second, and the teams kick alternatively in 5 rounds. If tied, of course, sudden death, however morbid sounding, begins in the same pattern until a winner is decided. Easy enough, right? No. In December of 2010, Ignacio Palacios Huerta and Apesteguia, both professors of economics and game theory, published a paper that revealed the psychological advantage of going first after analyzing results from years of shootouts. In fact, about 60% of games are won by the first team. The theory behind this is that the second team always has to catch up to the kicks of the first team, or also known as the pressure to equalize. Imagine that you're the first in your lineup for your country in a World Cup final shootout, and you walk out to the spot as the first team bags the first goal. Smash the ball in, and you've equalized the score. Miss, and the opponent has the chance to lead 2-0 before your local mafia can say assassination out loud 3 times. So what exactly is the resolution? The Premier League, among other organizations in football, are dipping their toes into the ABBA system, proposed by Palacios Huerta. In the conventional shootout, Team A and Team B alternate by A, B, A, B, and so on. In the new method, the teams shoot A, B, B, A, A, B, B, A, and so on in sudden death if needed. The new system is supposed to lower the pressure on the first shooter of Team B and to balance the advantage of shooting first. But being a new system, there just isn't enough empirical evidence to make a certain decision of the best kind of shootout. But when you don't have evidence, you have math. Imagine you're a totally, well, not corrupt president of FIFA and want to make penalty shootouts the fairest possible for both teams. But you don't care just about the and you want to do it in the most convoluted and mathematically amazing way possible. In comes the Thue Morse, or the fair share sequence. For now, let's just suppose that there's a penalty shootout that lasts forever, which I'm sure is a legitimate assumption that's possible in reality. But I hope you'll see the benefits of this later. So, first Team A shoots, then Team B. But to make the shootout fair, we now let Team B go first, and then Team A. So we shoot A, B, B, A. But wait, there's more. To make it even fairer, we continue with the previous sequence, except imagining if Team B began the shootout. So A, B, B, A, B, A, A, B. We continue the sequence in the style of inverting and adding until we sound like babbling babies. A, B, B, A, B, A, B, B, A, B, A, B, A. Keep in mind that each shootout still has one A shooter and one B shooter. There are multiple ways to produce the series, but I thought it was easiest to see the fair part of it using this method. If you're interested about why this is called the fair share sequence, there are great videos showing its cool properties. Essentially, if person A and person B are choosing things from a pile, they can use the Thue Morse sequence or fair share sequence to pick things fairly, instead of person A always getting the better item in each round of picking. So this gives rise to a couple questions. How do we even quantify the value of shooting at a particular position? Is a penalty shootout even comparable to sharing things in a pile? How exactly do we even compare kicking first against kicking second, and kicking 75th against kicking 76th? But that's the spectacular thing about the Thue Morse sequence. It actually doesn't even matter. Kind of. No matter how you compare the different positions, it will always be fair, as long as you follow a few math rules. Rule number 1. Pick a polynomial, any polynomial. We start with a polynomial function f. For those of you who aren't familiar with polynomials, just imagine a function where you plug in a number x and get an output f of x, which is calculated as a weighted sum of powers. So we have some number c1 times x to the power p, plus some coefficient c2 times x to the power p minus 1, and adding all the way up to cp times x, plus some constant. Keep in mind that these coefficients, c sub something, can be 0, so polynomials aren't as intimidating as they look. Some examples of polynomials are f of x equals x, f of x equals x squared, and f of x equals x to the 4th plus 2x plus 1. Rule number 2. Power of 2. Now in the Thue Morse sequence, pick your favorite power of 2, which we'll call 2 to the k, and write down the first 2 to the k number of terms. For now, let's just consider the first 8 terms, so k equals 3. Now we'll make a set 1 of all the locations of A in the sequence, starting with 0, and a set 2 in the same way with B. So in our case, 1 is the set of 0, 3, 5, and 6, and 2 is the set of 1, 2, 4, and 7. We're just splitting up the sequence by A's and B's. Now let's get back to the function f. Rule number 3, and the last rule, compare the powers. As long as the biggest power of f, in this case p, is less than k, then f of 0 plus f of 3 plus f of 5 plus f of 6, or the sum of all the outputs of f of the elements of set 1, equals the sum of all the outputs of f of the elements of set 2. So in our case, k equals 3. So f of x equals x works. So does f of x equals x squared plus 3. But f of x equals x cubed doesn't, as the highest power 3 is not less than 3. If we want higher power polynomials, we can always increase the power of 2. So that was a big mouthful of math, but what exactly does this mean? So let's say a penalty shootout won't go farther than 8 rounds, or 3 additional rounds of sudden death. This means we have 16 kickers, with 8 from each team. And according to rule number 2, our 2 to the k means that k equals 4. Now let's choose a function. We know that setting the tone early and finishing off strong in penalty shootouts seems to be a really important factor to winning the match. This means kickers 1, 2, 9, and 10 are usually the best kickers on the field. Then the importance of kickers drops off, because it's unlikely that sudden death is required. If it is, then kickers 11 and 12, being in the first sudden death round, will most often have the biggest impact on the result. Now let's compare the position of the player with their impact, with a bigger number denoting a bigger impact. So the importance of kickers first starts up high, then decreases, goes back up, then goes back down. So we want it to look something like a cubic equation, which has highest power 3. Or suppose you think the most important shooters are the first ones, and decreases from there, so you end up with a line. Or even, the importance maybe could decrease, then increase, like a parabola with highest power 2. No matter which one of these theories you have, you're right. The sum of the impacts of Team A always will equal the sum of the impacts of Team B, because we follow just a few math rules in the Thue Morse sequence. Crazy, right? More teams? No problem. The Thue Morse sequence can even be generalized into more variables with the same process. With 3 variables, you can start with ABC, then pretend B began the shootout, then pretend C began. So ABC, BCA, CAB, and so on, with these extended sequences having even more fascinating properties. Even if the ABBA system doesn't find its way into sport, we can always look to the Thue Morse sequence for some amazing mathematical properties. Or is it the Thue Morse Morse Thue sequence? Or the Thue Morse Morse Thue Morse Thue? I think you get it.